So I will go back a little bit in a dimensional analysis. That's we did this, but anyway, I don't mind going through that again, like a quick refresh. So we know that there are three dimensions that we'll mainly be worried about: length, mass, and time. And they are put symbols. L stand for independent of the units. It could be kilometers, meters, miles, whatever. It doesn't matter. So we call them all as length, as a one dimension. And the mass is capital M, time is capital T. So then let me erase this all. I've been talking to myself, it looks like. So we'll go through that again. So let's take this equation. What dimensional analysis tell you is every term in an equation must be of the same dimension. This is one such equation. So what are the terms here? V squared is one term, A squared is another term, B into A into X, that is another term. So term 1, term 2, this whole thing as one term. I want to pause a little bit to make sure that you are listening to me. Are you? Somebody say
Yes,
something.
yes, we are.
Yes, we are
Thank
listening.
you. All right, thank you. Thank you so much. Right. So 5, let me do something different. Say 5 meters equal to 3 meters plus 2 meters. I mean, it is correct, right? 3 meters, meters, meters. But if I say 5 meters is equal to 3 meters plus 2 kilogram, okay, numerically it is correct. 5 is equal to 3 plus 2. But dimensionally it is not. The first term of length dimension, the second term is also length, and the third term is mass dimension. You cannot mix dimensions. Therefore, this is dimensionally inconsistent, or you'll say dimensionally incorrect. So that's what we do when we say we are doing dimensional analysis, to make sure the equation is dimensionally correct. So let me get this out of the way. Let's focus on this. What we are going to do is to use our dimensional analysis to get the dimensions of what we don't know. He's asking in the question, find the dimension of A and find the dimension of B. V is velocity, and you're supposed to know what the dimension of velocity is. Some people might object here. We didn't learn what velocity is. No problem, don't worry. In that case, I'll tell you. Dimension of velocity is L over T. You will be properly learning it later, soon, in the second chapter. But for the time being, I will tell you. Dimension of acceleration is, if someone remember the unit of acceleration, you'll immediately tell me meter per second square. That will give away the dimension. Meter is length, second square is time square. And x is position, so the dimension of position is length. So you must know this bit to answer this question. Okay, I'm giving it to you. Right. Now I'll take the first term here, v squared has the dimension of length divided by time for velocity, but as it is squared, it will be length divided by time squared. Okay, right. So let me pause again. At any time I go, mute or for some reason, please use the chat or something to send a message. I hope I am still audible. You can hear me, right?
Yes, sir.
Okay, thank you. So let me continue. So I know the dimension of the first guy, then I will use my knowledge. Every term has the same dimension. I will say the dimension of a squared must be L squared over T squared. What does it tell me? If you take the square root, because what I need is the dimension of A, that must be L over T. So I found the answer to the first part. The dimension of A is found. Now I go to the third term, which is BAX. I will again tell myself the dimension of BAX also must be L squared divided by T squared. Right? Okay. Now, next step, I'm going to this left side. I will say the dimension of BAX must be dimension of B multiplied by dimension of A multiplied by dimension of X equal to L squared over T squared. Okay. Now, I will continue. I know what is the dimension of B. L over T squared. I know what is the dimension of X. L. There it is. Now you need to know some algebra, basic algebra. So you can see that on the left hand side I have L squared, right hand side also I have L squared. So L squared cancel with L squared. Similarly, you can see on the left hand side we have a 1 over T squared, right hand side also we have 1 over T squared cancel with T squared. So what is left is we have on the right hand. Yes, very good. Very good. Thank you. Yeah, it helps me if you time to time someone make a sound, so I know you are there because I kind of no one is in front of me. I need. Thank you. So B equal to 1. So we found D is the correct answer, right? A, we found it to be L over T. See, L over T can be written as L T to the power minus 1. And we found B to be 1. 1 means dimensionless. Okay, that's what you need to remember. If you get the dimension of something to be 1, that means it is m to the power 0, L to the power 0, T to the power 0. You know, anything to the power 0 is 1. So this whole thing is 1. When you find the dimension of something to be 1, that means that quantity has no dimension. This whole thing together, not whole thing, the B, dimension of B is no dimension. The quantity B is a dimensionless quantity. Okay, there can be dimensionless quantity. Right. If something is a ratio of the same unit, up and down dimension cancel, so you have a quantity which is dimensionless. All right, we can go to the next. This is also.
Doctor?
Yeah, sure, please.
I'm
listening.
Okay, thank you. You said 1 is dimensionless. What about 0? The same or no?
You will never get, when you do this dimension analysis, you will never get something to be having a 0 value. It is not possible. The worst thing you can get, it is you'll never get something like that. So MLT, M may be M to the power 0, anything to the power 0 is 1, right?
Oh, yeah.
Yeah. So L to the power 0, so that is also 1. Maybe T to the power, maybe you will get it to be minus 1 or something, okay? So you will never get that answer. Whenever you work it out, and a quantity must have something m to the power something, or everything is 0, that means you will get it to be 1. Yeah. Let's do this question number 6. Velocity v of an object is given by the equation v squared equal to a squared plus. Is it the same question?
Yes, sir. It's the same question.
It's the same.
No, I don't know. It looks like same. V squared. Yeah. Why is it? Ah.
Sir, you're muted.
Sir, we can't hear your voice.
Your mic is muted.
Oh, yeah. All right. Now, am I okay?
Yes, sir.
Oh, thank you so much. I don't know why it happened. Right. Now I am not muted. You can hear me. We go to the next topic, proportionality. It's an easy one, but also this example might scare you a little bit, because I'm bringing in an example from biology, life sciences. Sometimes you want to see if there is any connection between two things. Like this example is, you might think when the body size increases, the brain size will also increase relatively, right? Okay, that's something. So we are small, our brain size will be proportional, somewhat proportional in some way to our body mass. So it seems to be true, but not linearly. What I mean by linearly is when the body size doubled, do you expect the brain size also to be double? That is linear. Okay, 2 times become again 2 times. It's like, say, suppose somebody is 1 kilogram, his brain size is 1 gram. So when he become 2 kilogram, the brain size is 2 gram, and so on. So that is linear. Not necessarily linear, but seems to be some connection, correlation. So people took a lot of data between different species, okay, not the same human. Human as one species, say a bird, one particular bird, another species, and so on. And they found there seems to be a rough correlation. The brain mass is proportional to, that's what the term, this means proportional, not infinity. Proportional, the body mass, not to the power of 1. If it is power of 1, that is linearly proportional, but rather to the power of 0.68. So this is proportionality. That is something very important. Direct proportional mean to the power 1, okay, linearly. But it doesn't have to be like that. Sometimes it is inversely proportional to the power -1, and so on. So people, take a plot it, but this is a log graph. Let me talk about that a little bit. See, if 1 here, and if it is 10 here, so what is the interval between 1 and 10? 1, if you 10 minus 1, it's 9, right? So after similar interval, this should be 19, right? But it is not so, because a log graph. So this is actually 10 to the power 0, that is 1, right? This is 10 to the power 1, that is 10. This is 10 to the power 2, that is 100. This is 10 to the power 3. So spacing is a log graph. Okay, probably you must have seen log graph, but if you haven't seen before, now you are seeing it now. The same thing here. This is 10 to the minus 1. So here again 10 to the power 0, 10 to the power -1, 10 to the power 1, and so on. So log graph, both x-axis as well as the y-axis is in log scale. So when you plot this kind of a graph, and if there is a proportionality, you get a straight line, but of course it is not a perfect straight line. There seems to be some correlation. Most of the, you can draw a best fit line which suggests certain proportionality. The slope of this line is what this index is, 0.68. So that's how you find the proportionality. So we are bringing in a nice example in life sciences, so it is relevant to medicine. So the brain size versus brain mass versus the body mass, it has this correlation. And so there are some interesting facts here. I suggest that you read the textbook. You have it available as PDF file. It must interest you because you are medicine, pharma, life sciences people. You must be able to guess this 31. Somebody can guess who that is? Which species is that? Hello?
Which one, Doctor?
This number 31. See, he's an outlier, right?
Yeah.
Meaning he has more brain mass than the average line here. For the given body mass, it looks like somewhere around 80 kilogram, whatever, 10 and 100. So looks like, how can you guess who that is? Which species? Who has a brain mass relatively higher compared to the body mass, compared to other species of animal? Human.
Humans.
Homo sapiens. Yeah. Okay. So there is very interesting, this kind of mathematically analyzing what's happening in the physiology or the life sciences. Okay. Right. So this is a nice example. We are talking about proportionality, right? So something proportional. You must have done this in your math class as well. But it's a simple proportionality questions we're going to give you. So here is one example. Suppose in a certain fictitious island, the arm length of a person is directly proportional to the height of that person. So let's say there is a certain island, because that doesn't happen exactly like that. So you will take the arm length of the arm, and the height of the person. Okay, in a certain fictitious, what is fictitious mean? Imaginary, not a real one. So let's say A for the arm length, maybe somebody, a small child, maybe he has an arm length of, let me put it in centimeters, so let me make up some numbers. So maybe very infant or someone, she probably has a short arm length. So let's say 3 centimeters. The arm length is maybe too small. Okay, I don't know. I just want to put some numbers. Don't worry too much. Say, and the height is 30 centimeters. Just I'm imagining. Okay, I cannot be very accurate. Just put like that. And let's say when someone is 6 centimeters, what do you mean by proportional? Now here there's a doubling, right? 3 becomes 6, 2 times more. So that will make, if it is exactly proportional, the height will be what? Can someone answer it, please?
60 centimeters.
Yeah,
60.
very good. Very good. So that's the meaning of proportional, directly proportional, exactly proportional. That means A is directly proportional to H. So if you want it to write as an equation, A equal to, you replace the proportionality by an equal sign, some constant multiplied by h to the power 1. You don't have to put the 1 now, because it's h to the power 1 is equal to h. Also h. So this is the meaning of direct proportionality. There is no addition or anything. So when h is equal to 0, A is equal to 0. When h doubles, A doubles, or when A doubles, h doubles, and so on. So in other words, the ratio A over h is a constant. When two quantities A and h are directly proportional, you can say the ratio of these two quantities, one to another, the order doesn't matter, is a constant. You can say A1 divided by H1 for particular one equal to A2 over H2. So it is both of them are equal to K. That means A1 over H1 is equal to A2 over H2. This is not something new, right? I mean, you understand what I am saying here. But at the same time, knowing these things will help you solve, which looks like a complex problem. But if you use these mathematical techniques, just saying the ratio is a constant when two things are proportional to each other, will help us solve question without thinking too much, because we have a system, right? The ratio of these two quantities is a constant. So let's look at this particular question, see how easily we can solve it, knowing how to do it with your math. Suppose in a fictitious island, the arm length A of a person is directly proportional to the height of that person. In other words, A, which stands for the arm length, is directly proportional to H, the height of the person. So now he is saying there's a certain man in this island whose height is 1.80 meters. Let me take this man as 1, okay? So the man number 1. And or maybe we use the same symbol here because he's the father. Okay, so let me call the F. The man is the father. So a certain man who is the father of a certain child, his height is 1.80 meters. So I will say this is the H of the father. And his arm length, so A of the father is equal to 82 centimeter. Then there is his son. His son, so in the same way, I can say this is the arm length. So this will be A of the son. S is for son. What is the son's height? The question is H of the son. Right. Now see how easily we can do it, because we know A and H are directly proportional, so this is the constant. So I can say AF is equal to K into HF and AS equal to K into HS. Or in other words, combining this, we can this cancel out. So you can say AS, the ratio AS over HS is equal to AF over HF. When two things are, and of course you can put it like this as well, it doesn't really matter. When A over H is a constant, then AS over AF is equal to HS over HF as well. I would prefer doing it this way. So we see A over H ratio is a constant. So AS over HS is equal to AF over HF. Now I can substitute what is given. AS is, the question is this, right? HS. Everything else is given. So AS is 70. HS is not given. AF is 1.8 and HF is, sorry, AF is 82 centimeters. AF is, HF is 1.80. Look at that. Only thing we don't know in this final equation that I wrote is HS. And you know how to solve this, right? I mean, little bit of algebra, make HS as the subject and you get it. But again, can give you a shortcut. I mean, you're allowed to use calculator, and the calculator can be used in solving mode. I want to show you something. I hope, yeah, I hope I can go to the, how do I go to my desktop? Okay, just to give me a minute. I want to do something. I want to get to my calculator, which is in my desktop. Yep. Right. Now back to my, yeah. Right. Let me go to my slides. Yeah. Are you with me? Just want to be sure.
Yes, sir.
Yeah.
Okay, thank you. Right. So The reason I brought the calculator is to tell you, I mean, okay, even if you think, okay, you're not really, if you think your algebra is not good, no need to worry. You just get the equation and go to your calculator and write the equation in the calculator. Okay, all these calculators, the Casio, I don't know, there are other calculators work in a different way. You can use it in a solving mode. So I will put this thing, the fraction 70, come down, divide by HS. So this is the only unknown in this equation, call it X, alpha. Okay, so, and bring it up, equal sign, alpha calc, that's equal, again, put this fraction, 82, come down, 1.80. That's it, solve this equation. So see, you don't even have to worry too much about converting. The 70 and 82 are in the same unit, in centimeters, and 1.8 is in meters, so the X will come out in meters as expected. So now how do you solve this? Shift calc. This is not the answer, okay, you have to be careful. This is what's in the store in this location X. From previous calculation, you have to press the equal sign again, and you should see this X equal to something. L minus R is this is calculator is verifying the answer. If this answer is substituted back into the left side and the right side of the equation for X is in the left side. So if the L minus R, the left side minus right side should be 0. If they are equal, they should be 0. So the answer is 1.536. Well, when it is rounded to 3 significant digits, you will see it here, 1.54. Right, good. So let me go back to my slide. Right, the final one, order of magnitude calculation, estimation. Sometimes, you know, you are in the field, okay, you are a doctor, you are working and you want to, let's say, you want to calculate something very quickly. I cannot think of an example as a doctor, but let me take this particular example. Yeah, it's also, you know, yeah, but I'll let some introduction. He's a physicist, okay, Fermi. He popularized this order of magnitude analysis. Now, you know what order of magnitude is. When you write any number in scientific standard notation, like 1.3 or something 10 to the power 3, this index 10 to the power, that is the order of this number. So this is in the 1000, right? So the order is 3. So if you have another number, let's say 0.032, so if you write it in scientific notation, 3.2 10 to the minus 2. So the order of this number is minus 2. So that's the meaning of order of a number, order of magnitude of a number. So sometimes you need to give an answer, not very accurately, but to the order. So you have to say, okay, for example, what is the volume of your living room in meter cube? So one should be able to make a quick estimate, okay, is it in the 10,000 meter cube or 1,000 meter cube? Only in the tens. 1,000 meter cube mean order is 3. 10,000 mean order is 4. So you need to know only the order. So that kind of quick calculation, sometimes very useful. Not sometimes, many times it's something a useful thing to do. So as a medical doctor, somebody can, you may have this question, how many times an average human heart beats before dying? We are not given any data as a doctor. Even not even a doctor, any human being or an adult human being, they should have should be able to calculate this very quickly in an order of magnitude. How many times? A billion times or 1,000 times? No, it has to be much more than 1,000 times. But can you calculate it very quickly in your head? Yes, you can. How? This is, I'm going to show you, slowly, but you're not, you're supposed to do very quickly, but as a method, for me to teach it, I have to go slowly. First thing you need to know, what is the average heart rate or the beats per minute, BPM, average. Somebody can answer that. Average heartbeat of, as a medical student, you should know that. Yes.
79 to 80.
70, 80, 90. Yeah. Okay. It doesn't really matter because what we are into, let me take 80. Okay. Like in this example. Even somebody else took 70, somebody else took 90. At the end, you will arrive at the same order. We will see. So let me take 80 because that's what I have taken. So the average beat of a human heart is, sometimes when you do exercise, of course, your heart rate goes up. But on average, yes, something like 80, 90, so on. And what is how long a heart lives? In other words, how long a human being live? It's also, we need an average value. What would you say? What is the average age of a normal person? The average person.
60 to 70.
70. Okay, I have taken 70, so let me stick to that. Right? You will find it doesn't really matter. It may be a little bit here and there, doesn't matter. So now these are the two things we need to know to calculate it, because if you beat 80 times in a minute, and if I can convert the 70 years into minute, then you know how many times the heart will beat, right? Because minute will cancel minute, you will get the number of times the heart will beat before the 70 years passes. The minutes in 70 years has been used, so you get the answer. So you have to multiply 80 by 70 years converted to minutes, right? You get the idea. Right. Now let me go to the next part here, the second line. So 80 times per minute, good. And I have to convert the 70 years to minutes. Now see how it is done. This is the conversion of unit part. Yes, I will go step by step. I'll convert the years to, this is the conversion factor. 1 year is 365 days. Right? So year cancel with year, you get, if you multiply 70 by 365, you convert the years into days. But that's not good enough. I need it to be minutes. So the second step, now you have a day. Day should cancel. So 1 day is 24 hours. So you have converted the day into hour by multiplying by 24. Good. Hour is not good enough. I want it to be minutes. Now you know the conversion between hour and minute. 1 hour is 60 minutes. Hour is down. Hour will cancel with hour. That's it. So if you multiply 70 by 365, multiply by 25, multiply by 60, that will convert the 70 years into minutes. So this is the calculation you have to do to get the number of times the heart beats before it expires or before it dies. Right. Now we come to this is what I'm supposed to do. Are you going to do the calculator? No, you are in the field, you are on work, okay? You just want to do it in your head. So now I'm going to show you how to do it in your head. It's an order of magnitude calculation. So you go like that, okay? I'm showing it, step by step, but it is not how it should be done. But anyway, I have no choice. 8 can be written as 8 into 10. 7 can be written as, let me Yeah, how would I put it? Okay, 8 into 10, no problem. 8 into 10, 10 to the power 1, right? And 7 can be written as 7 into 10, 10 to the power 1. Is 365. I will just put it as, it is actually 3.65 10 to the power, tell me, 10 to the power 2, right? So I will
Yes.
round it to 4. Because I can round very freely because it's more than half what comes. So 4 into 10 to the power 2. Okay, I got this one is 2.4 into 2.4 again. I just want just one number. 2.4 will be 2 into 10 and 6 will be 6 into 10. I think I have done it here, so I don't know why I'm repeating it. Okay, right. Anyway, it's good to see my process. So 8 become 8 into 10, 70 become 7 into 10 to the power 1, 3.6 become 4 into the power 2, 24 become 2 into the power 1, 60 become 6 into the power 1. Right, next step. This is 10 to the power 1, you know how to multiply indices, right? So it become addition. 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 1 is 5, and 5 plus 1 is 6. All the 10s get together, it become 10 to the power 6. And the numbers that are left is this, 1-digit numbers. Do this very quickly in your mind, okay? So knowing a little bit of this dodging table will help. 8 into 7 is 56. Take this all three together. 4 into 2 is 8. 8 into 6 is 48. Again, you don't have to, even though you don't remember exactly 56, you can round it to 6. So it is 8 into 7 is 60. Okay, round it. 48 will be 5 into the power 1, 10 to the power 6. Now comes 6 into 1 plus 2 plus 6, that is 10 to the power 8. 6 into 5 is 30. And that's it. Okay, I think I come to the last slide. Yes, this is the last slide. Yeah, please tell me. Yes, I'm listening. Yes.
Nothing. I say the last one.
It's good. Oh, thank you. Right. So you followed everything. Alhamdulillah. This is being recorded, so I will post it. The main reason I did this online, because I don't want to be left behind because we have other classes, other sections have 3 meetings. We have only 2 meetings, but with a long duration. But unfortunately, because I lost my voice, I couldn't complete it. That's why I did this. Now we have it recorded. Even those who did not come today, no issues. They can look at this recording. If you have any questions, of course, you can come to my office and ask me. I will be happy to explain again. Right. But when the week starts on Monday, I will start chapter 2. Thank you so much for coming and listening. So can I end now? Any questions?
Yes, sir.
Yeah.
No, sir.
No question. Thank you. Yeah, you have a question,
sir.
please ask me.
Thank you.
No, thank you. All right, see you.
Thank you.
Assalamu alaikum. You're welcome. Thank you.
Alaikum salam.
Thank you, Doctor.
You're welcome. Thank you. So how do I finish this? Stop sharing.